Hello friends, so we are going to start concepts of networking series and we are going to see today is OSI layer model. So let's understand what is OSI layer model is. So OSI means open system interconnection, and this model is the conceptual framework that standardizes the functions of the communication system, make it easier to understand and design network systems. So your uses are basically standardization, troubleshooting, interoperability and the scalability. So basically what is OSI model? It is the standardized conceptual framework that we use to make communication or the network systems. Okay, so what is basically do it? It helps it make it simpler for diagnosing network issues layer by layer. It provides interoperability, ensures the different systems and devices can communicate effectively, and scalability. It helps design and expand the network efficiently. So that's what I have written here, but let's understand what is OSI layer. It is basically a standard, we can say. Standard means a procedure to make a proper and error-free infrastructure for the network systems or the communication system. Okay, so that's it. So we are going to see one by one what are those standards and what are the protocols, what are the layers in the OSI model one by one. So there are 7 layers in the OSI model. First is physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. We are going to see one by one in detail. So let's start with the physical layer. So the physical layer is the lowest layer of the OSI model. It is responsible for the transmission of the raw data bits over the physical medium. Okay, so the functions are convert digital data into electronic or optical or the radio signals for the transmission. The key components are given in the images. You can see transceivers, cable modems, socket connectors, wired media cables, wireless media antennas, hubs and repeaters, all such physical devices which helps for the interconnection between two devices such as wires, cables, all those comes in the physical layer. All the physical medium comes in the physical layer, that's it. So protocols are RS-232, USB, Ethernet and Bluetooth. Transmission modes are it supports simplex, half duplex, full duplex communication. Physical characteristics define hardware specifications like voltage, pin configuration and signal timing. Error handling. So in physical layer there is no way to do error handling, so it does not perform any error detection or correction. It only facilitates bit level transmission of the data. Examples are given in the images. You can see Ethernet cables, optical fiber cables, wireless transmission hardware, that's it. So basically what physical layer do, if you see the overview, it basically works on the raw data. It transmits the raw data bits to further layers for the data transmission. So basically transfer the raw data bits that you have to remember. Okay, let's go further. So second layer, that is data link layer. It ensures reliable data transfer between directly connected devices. Okay, so it organizes the data into the frames for the transmission. Okay, so whatever the raw bits are coming from the physical layer, it organizes those raw data and make the frames of the structured data packets. Okay, frames means itself structured data packets. It handles error detection and correction. It manages flow control to prevent the data loss, and it is responsible for MAC and LLC sublayers. What is MAC? Is the media access control. It uses MAC addresses for device identification. Any devices which comes in the data link layer are identified by their MAC addresses. Control access to the physical medium. Okay, and the protocols in the data link layer are the Ethernet, Wi-Fi, PPB, SDLC, ARP. And the devices we use are the bridges, layer 2 switches, I'm saying layer 2 switches and access points comes in the data link layer. Okay, so let's go further, and I hope you guys understood what is data link layer is. Third layer of the OSI model, that is network layer. So what network layer do? So it handles routing of the data between devices across multiple networks. Okay, not only network, multiple network, different networks. It divides data into the packets for the transmissions. Okay, so in physical layer there is raw data. In data link layer there are frames are the organized data which is coming from the physical layer. Okay, so physical layer sends the raw data. Data link layer organize that data and form the frames are the structured packets. In network layer it divides data into the packets. Okay, so let's remember that thing. Physical layer raw data link layer frames, network layer there are packets. It manages logical addressing using IP addresses. In data link layer what does it do? It use MAC addresses for identification of the devices, but in network layer it manages logical addressing using the IP addresses. Okay, it provides path selection and best route determination. Okay, so what is path selection? If there is a source and destination are both in the different networks. Okay, so if we have to go from the source to destination, there must be some path should be followed, and that best path which helps for the reliable data transfer are managed in the network layer by the routing devices such as routers. Okay, router do that functionality, and also you can see the image. There is 6 Cisco router. So all the routers comes in the network layer, and all the routing protocols also comes in the network layer. Also there are some layer 3 switches. In the previous layer we have seen the switch, but I said especially layer 2 switch because it come in the layer 2, and in layer 3 there are layer 3 switches which also do the routing of the data between networks or anything that will be done by the router itself. Okay, it ensures packet forwarding through the routers. Okay, that I have already told. Responsible for the fragmentation and reassembly of the packets. Okay, so what is fragmentation? Means basically if there is a larger packet, then cut it into the small pieces and form the small packets. That what we call fragmentation. It supports both connection oriented and connectionless communication. Okay, both connection oriented and connectionless communication. And network layer are protocols in the network layer are IP, ICMP, ARP, RIP. RIP is the routing protocol, OSPF, BGP, all those are the routing protocols. Also there is a one called EIGRP, but EIGRP is very specific for the Cisco routers only. Okay, so let's go further for the 4th layer of the OSI model, and that is transport layer. Okay, so basically as the name suggests, transport means delivery of the data. Okay, so what does it do? It ensures the reliable end-to-end communication between the devices in the network infrastructure. Okay, it is responsible for the accurate data delivery. Okay, it divides the data into the segment for the transmission. Okay, what does it do? It divides data into the segments. In network layer, it divides the larger packets in the smaller pieces, and we call it frames. Okay, and in transport layer, what we do? It divides the larger data into the smaller packets or the segments. Okay, we use the word called segments in the transmission for accurate data delivery. It provides error detection and the corrections. Okay, it manages flow control to prevent the cognition or the collision of the data. It supports connection oriented and connectionless communication. What is connection oriented? There is TCP communication, and connectionless, that is UDP communication. TCP is the more reliable and it performs accurate data delivery. UDP is non-reliable, connectionless, and it basically used for the broadcast mainly. And so also in the transport layer, it handles port addressing for the application identification. Okay, it ensures proper sequencing of and reassembly of the data. Okay, what does it do? Proper sequencing and reassembly of the data. Whole data is in the packet format, not properly organized, so it basically arrange that data in proper sequence and do the reassembly of that data. That's it. The protocols in the transport layer are the TCP, UDP and SCTP. Okay, So let's go further. I hope you guys understood. Fifth layer, that is session layer. Okay, so what session is basically, it is the medium of conversation between two devices. Okay, how two devices should communicate with each other, that is managed by the session layer. It establish, maintain and terminate the sessions of the communication. It synchronizes the data exchange with the checkpoints. It handles dialogue control for the full duplex or the half duplex communication. It provides session recovery in the case of interruptions. It ensures proper data exchange between the applications, and the protocols are NetBIOS, RPC, PPTP, SMB. Okay, so basically what is session layer? Just understand the overview. It manages the control the communication session between the devices. If two devices want to communicate, they first need to make some sessions, form some session between them, and that session is used for controlled communication between those two devices. Okay, and when that communication happen, that data need to be in the synchronized format. If data is in the some random format, randomly accelerating in the network infrastructure, you cannot properly find out what is that data is, and you cannot get proper information from it. So synchronization of the data is very important, and that is done in the session layer. So let's understand half duplex, simplex, full duplex. What that means. So here you can see that image. So simplex communication, you can say the broadcast. If there is a one source and multiple destinations, then we called it the simplex communication. Half duplex means when communication happen alternatively, like you are sending message to someone, and after seeing that message they send you a reply for that message. So before, if you can't send the message, they cannot reply you back. Okay, firstly you have to send the message, then they see that message and then they reply you back. That is called half duplex. And if both source and destination are communicating at the same time, then we call it full duplex communication. So that's it for the session layer. Let's understand presentation layer. So as name suggests, presentation, it is a translator between the application layer and the rest other layers. So rest other layers, they do transfer the data, such as physical layer transfer the raw data link layer from the frames and organize that data. Network layer, basically it make the frame fragmentations of the data, form the packets from that data. In the transport layer, we have seen the segmentation of that data happens. In session layer, we make the sessions for the communication between two devices, and in presentation layer, it acts as a mediator or the translator between all those layers behind it and seventh layer of the OSI model, that is application layer. So basically what does it do encrypt and decrypt the data. Okay, it do encrypt, decrypt the data. It translate the data in the human readable format. Okay, all the data that is in the machine language, or we can say 0 and 1s. Presentation layer convert that data into the human readable format. It do the encryption for the secure data during the transmission. No one should get that data, make it corrupted, or the what we can say no one can get access of that data without the authentication, proper authentication. So that's why in presentation layer it do encrypt that data. Compression, it reduce the data size for the efficient transfer. Common protocols are ASCII, EBCDIC, JPEG images, PNG, all those images, videos, compressions, email attachment encoding are present in the presentation layer. So let's go for the seventh layer of the OSI model, that is application layer. Is basically, as the name suggested, all the applications such as browsers, emails, videos that you see on the YouTube, those all come in the application layer. Okay, it provides network services directly to the end user and the application. So end user not directly go to the data and try to read that data. Okay, you cannot read directly, you cannot go directly and read that data because it is in the encrypted format or something. To read that data, you must have some mediator called application. You must have some mediator which we call application. Through the application you can read that data, and that's why we are the end users. We use the application to read that data. Facilitates communication between the software applications over the network. It supports various network based applications. Okay, you can see the images such as web browsing, emails, those are the application. Okay, defines the protocol used for the communication between the systems. Okay, also there are common protocols in the application. There are HTTP, HTTPS, SMTP, FTP, DNS, POP3, IMAP. It ensures user-friendly interfaces for the network interaction. Okay, that's it for the application layer. So what we have seen whole OSI model. There is another model exists, that is TCP IP model, and if you want to know about that model, you can comment in the comment box, and we will see in future videos about the TCP IP model also. So that's it for the OSI model. It's basically the standard for making proper communication systems or the network infrastructure. So lastly, thank you for watching video. Subscribe my channel for the next sessions of the concepts of networking. Thank you.